The space right above our heads is this incredibly complex environment that we rely on for just about everything, from GPS to the internet. But it's getting dangerously crowded up there, and that raises a really critical question. It's a question that experts are taking more and more seriously. I mean, think about it. What if our ability to actively manage all that traffic in orbit just stopped? Maybe from a massive solar storm or a catastrophic software bug. How long would we have before things started going very, very wrong? Turns out, the answer is a shockingly short amount of time. 5.5 days. That's it. This number is actually a brand new metric, one designed to measure the stress on our orbital environment. And it's a pretty stark number, isn't it? It really reveals just how fragile our foothold in space has become. So to really get a handle on what that number means, researchers have come up with a really powerful analogy. They've started calling our situation an orbital house of cards. This whole house of cards depends on thousands of collision avoidance maneuvers every single day, just to keep it from collapsing. It's a system that's fundamentally built on the assumption of constant, perfect, error-free management. You take that away, and the whole structure is at risk. So, you have to ask, how did our orbital house of cards get so fragile in the first place? Well, let's dive into the data to really understand the scale of this problem. The numbers here, they paint a pretty vivid picture. I mean, just look at this. The number of launches per year has absolutely skyrocketed, especially since 2020. We're setting new records for space activity every year, and a lot of that is driven by the deployment of these massive new satellite constellations. And, of course, more launches means more objects. This graph shows that exponential growth perfectly. But here's what's really fascinating. Look at the type of object. For decades, the biggest problem was debris from old collisions and explosions. But now, for the first time ever, active and defunct spacecraft actually outnumber fragmentation debris. That's a huge shift, all thanks to these new large constellations. And when we say objects, we really do mean everything. The official definition of orbital debris covers the whole shebang, from entire dead satellites and old rocket bodies, all the way down to little bits of mission-related junk, and even tiny flakes of paint. And all of it is screaming along at over 17,000 miles per hour. Now, this debris isn't spread out evenly, not at all. This density chart is brilliant. It shows you exactly where the traffic jams are. You can see these massive peaks in certain altitudes, especially right around 550 kilometers, which, surprise, surprise, is dominated by megaconstellations like Starlink. And all that density creates constant, relentless risk. In those super crowded orbital shells, a close approach, that's when two objects pass within 1 kilometer of each other, happens on average every 22 minutes. Just think about that. That's the timescale we're dealing with up there. So this situation, it didn't just happen by accident. If you look at it from a legal and economic perspective, it's actually a predictable outcome of how we've governed, or maybe more accurately, failed to govern our shared space in orbit. There's this classic economic concept called the tragedy of the commons, and it describes our orbital debris problem perfectly. You see, Earth's orbit is a shared resource, kind of like international waters or the air we breathe. It's open to a lot of different users. And here's the crucial point. The benefit of launching a satellite goes to one single operator. But the cost, the increased collision risk from any debris it creates, that cost is shared by absolutely everyone who uses that orbit. This creates this powerful incentive to just keep launching more and more without really having to account for the collective risk. And the thing is, our international space law just hasn't kept up. For example, you're only liable for a collision if you're at fault, but nobody has clearly defined what fault even means in space. There are no established rules of the road like we have for ships at sea. And get this, nations legally own their dead satellites forever, which means nobody else can go up and clean them. Okay, so the stakes are getting higher, the legal framework is way behind. How are the actual satellite operators responding to this growing risk in the real world? Well, one of the most fascinating strategies actually involves the sun. You see, solar activity follows this 11-year cycle. When the sun is active, it heats up and expands our upper atmosphere. This creates more atmospheric drag, which naturally helps pull old satellites down. But during a solar minimum, that drag lessens. So in response, operators like Starlink are proactively lowering their orbits to stay in denser air. They're literally using our own atmosphere as a kind of natural, self-cleaning tool to make sure their satellites deorbit quickly.
But passive measures like that aren't enough. Not even close. Just listen to this number. In one recent 6-month period, Starlink satellites had to perform over 144,000 collision avoidance maneuvers. That breaks down to an average of nearly 800 times per day. 800 times a day, an operator had to actively steer satellite out of harm's way. That just underscores our total reliance on this constant active management.
And this brings us right back to that number we saw at the start. It's a new and I think crucial way of thinking about the risk we've built right into the heart of our orbital systems.
It's called the crash clock, and basically it's like a doomsday clock for orbit. It asks a simple question. If we lost all ability to maneuver our satellites right now, how long would it take for a potentially catastrophic collision to become statistically likely? It's a direct measure of our dependence on perfect, nonstop operations. And this, right here, this is the key takeaway. Back in 2018, before the era of megaconstellations really kicked off, the crash clock stood at 164 days. We had months of buffer. Today, it's just 5.5 days. Our margin for error has shrunk from months to less than a single week. So what does that really mean in practical terms? Well, it means if we lost control today, there's a 17% chance of a potentially catastrophic collision within the very first 24 hours. A shorter clock signals that we have drastically less time to recover from something like a major solar storm, a widespread software failure, or even a simple miscommunication between operators. And all of this leaves us with a really critical question. We are getting immense benefits from this new era of space activity. There's no doubt about that. But at what cost? Are we actively building a sustainable future in orbit? Or are we just stacking the cards higher and higher, hoping the table never, ever gets bumped?